Good morning, everyone. Good afternoon. Good evening. It's a little strange talking to a camera. I'm not used to it. I'll imagine that you guys would be watching me. I'll imagine that and make a presentation. So today's topic is about how do we redefine CCPM for R&D projects. I'm sure most of the practitioners out there would have seen a problem in their implementations. And the problem would look something like this. When they open up the portfolio chart after, let's say, 1 year of implementation, if they go back to the site, they won't be surprised to see a portfolio chart where almost every project is in red. It's not just in red, but if you extend the y-axis to include 150% buffer penetration, you would see many projects out there. It is not a rare thing to see after 1 or 2 years of implementation. So many projects are in red, and we all know the SOP says that if project is in red, we need to take actions to bring the project back on track. So what happens typically in such environments is there are two ways to approach the problem of reds. One is the classical way, where whenever a project is in red, the first thing that we tell our clients is take a buffer recovery action, right? So every project review meeting ends with a buffer recovery action. Now just imagine when many projects are in red, actually it triggers expediting action across many projects, which in turn leads to multitasking, or worse, people try to somehow show task closure even though it is not perfectly closed to show some percentage completion. So all this kind of stuff keeps on happening, which actually puts more delays into the project and hence more reds. So this is one way people get into the vicious loop. Basically, you end up dismantling everything that you have implemented in terms of a stable priority system, in terms of no multitasking, in terms of full kit. Many such things starts getting violated. Now there is another approach that people do when they look at the portfolio of projects and it's all red. They say, okay, now let's try to clean it up. So there is a dominant voice that will come up and say, let's clean it up, let's reschedule, bring every project back to green. But slowly and surely, the same project starts getting into red. Now, once you start doing this rescheduling often, actually the top management loses control on the project. The project review meeting, if you just reset the baseline, they get a weak sense of control. Okay. And as a result, the review meeting itself becomes ineffective. If you keep on rescheduling, the review meetings loses their significance, and slowly, without a good review, projects can also get delayed, and that also can contribute to the reds. So either way, if you see, this kind of thing happens, and basically, if you see, what we have done here is the as-is environment has not really transformed to the new environment. It's just that the lingo has changed. The projects are delayed, and in the older environment before CCPM also projects were delayed and people try to expedite it, or people try to reschedule things, and that's the typical conflict that used to be there before the CCPM implementation. Now, why does this happen? And I want to focus this discussion on R&D environment itself. And my claim is that there are basic assumptions of the R&D environment which the CCPM is not able to meet, the original CCPM. And the starting point is the objective itself. So if you look at the original CCPM for multi-project environments, and if you go through the SNT, the objective stated was it was meant to deliver high on-time performance. And when I say high on-time performance, it is as per the originally planned date. It's not as per the latest revised date. Right, it's as per the original planned date. It promises very high level of due date adherence, reliability around the due date. Right now, what does this imply? When you promise a due date, it just implies that the solution is actually very sensitive to the initial planning and the scheduling that you are doing. So that becomes very, very critical, that the initial planning and scheduling has to be as close to the reality as possible. Okay, it should not be way off the mark. Number two is just making a single project plan is not important, and the number two need is to ensure that all the queuing delays are accounted for while setting the due dates. And that's, we all know, is the process called pipelining, where the projects are pipelined based on a most constrained resource or a virtual drum, right? Basically, we stagger it and get a due date. So that's the end of planning, where we get a valid date for each of those projects. Now, once this planning exercise is done, we tend to believe that this is a good job done, and hence the execution, the entire focus shifts to subordinating to the date that has been planned, and that is how we will meet the on-time performance. Now, what are the subordinating actions? The first is that the priorities has to be derived from the buffer colors. So, which means that if the buffer is red, which is a very high chance of missing the date, right, and that takes precedence over yellow and the green colors. And the second is, if the project gets into red, one needs to do a special action, expediting action is also technically allowed, and you do what is known as a buffer recovery plan. So, people who have done this would have seen how buffer recovery is done. So this becomes a very, very important part of the review meeting. Now, the assumption here is that we have done a very good staggering, the pipelining, right, and the scope of the project is very well defined. So these kind of recovery actions should not impact the entire pipeline, right? And if you see, these assumptions are borrowed heavily from the drum buffer rope solution. Even if you look at drum buffer rope solution, what we try to do is, in the planning, we try to solve the problem of due date quotation by trying to resolve the load on the bottleneck, and that's how we get a valid date. Yes, product mix can change, and for a changing product mix, there are better algorithms to account for that as well. But basically, the aim is that during planning itself, we have a capability to give what is known as a reliable due date. And once that is set, in execution, we focus on the color priorities and try to take actions to ensure that the so-called reds do not miss the due dates. Now, that's what is borrowed from DBR. Now, what are the assumptions in the DBR environment? One is that all the potential bottlenecks, they are dominant. Okay, even if the product mix changes, we know where the new constraint is going to be, and more important, it stays stable at that place, right? And the other important assumption is that not only the touch time is insignificant portion of the lead time, but the touch time also stays stable. It's not that you plan for X work and it becomes 2X during execution. It is unheard of in any DBR environment. Now, coming back, let's check what is the implicit assumption. Since we have borrowed from the environment of DBR, there is also an implicit assumption. CCPM does recognize that the touch time is very high, and that's why it differentiates tasks from a project buffer, which DBR does not. DBR just puts entire thing as just the buffer. So here it does recognize that the touch time is high, and that's a need of having a project buffer which is segregated from the task times. But it also assumes that the touch time itself will stay fairly stable throughout the execution. Okay, and that's a big question mark. So because of this assumption, we believe that during the initiation of the project, we can do a very good work of planning, because the scope is very well understood, and the dependencies are also very well understood, and that's the real question mark. If you look at every R&D project, and if you look at R&D project, it goes through various phases. Each phase, if you see, there is always a check on what work we have done and is it right or wrong. It goes through some kind of I would say a testing. For example, once the concept is finalized, you go through what is known as a concept validation, right, where people run simulations and so on and so forth. There is something called a product validation. People, after making the product, they check that does the product meets the functional expectations, and then you go for a process validation, whether you can produce the product, and then also goes for production validation, which says can you produce in the required quantities while maintaining the efficiencies. If you see, each one of this is actually a question mark, and end of each of this time, it opens up a topic. It can lead to rework, cycles, that means the scope itself undergoes a change. Now, many environments have these kind of gates at a project level, but even in a large project, while you are making drawings, while you are even making concept around, let's say, a small portion of the project, you might be going ahead and trying to test what is it all about, is it really right, did I go in the right direction. So this kind of a questioning actually creates an environment where there are two wastages, right? The one wastage is what is typically called the I would say a type 1 wastage, which is basically all the wastages related to expediting, missing out on the full kitting, multitasking. This is what is called a type 1 wastages. But there is something called a type 2, which is not really a waste. It is actually a value added rework which comes from answering these questions. Is my concept okay? Is my product okay? Is my process okay? Is my production efficiency okay? Right? All these kind of questions, the answers to that is provided through these phases in the project. And whenever I try to answer this, I get new knowledge, and this new knowledge actually leads to rework. And it is not a wastage. It is actually a value-adding rework. Every time I test a prototype, I learn 5-6 things that failed, and that gives me a feedback loop, and I try to redo things. So this is where the scope, particularly when you're trying to initiate the project up in the beginning, you can never be sure about the entire scope of the project, right? And this is where I would say that the scope variability is extremely high for the R&D projects, right? Now, very important part for us is now to recognize that the scope variability is part of R&D projects. Is to first accept it, because once we accept it, then we can create a great solution. So basically, when we say scope uncertainty is very high, which means that the initial baseline that we have set for the project, it will undergo a change, okay? And which also implies that because of this high scope variability, that the bottleneck resolution that I try to do during pipelining, it's a big suspect. Because if the scope changes, the so-called leveling of the load that I have done, it might be wrong, okay? So also the other thing that we have to be careful that, when we are talking about cutting things by half, we don't know what we are really cutting, right? When we say we're cutting things by half, we are actually trying to kill the student syndrome. And it's a wasteful student syndrome. We try to do that right in the planning phase itself when we try to cut the duration by half. But when you don't know what the entire scope, you don't know what you are really cutting, and that really creates what we call as a Procrustes syndrome. Procrustes, if is a mythical bandit who had a cord of a particular size. So every time he used to get a passerby in the jungle where he used to hide behind. Every time he saw a traveler, he used to capture him and try to fit him in the bed. If the person, the height of the person was lesser than the bed, he would stretch him out, right, and then kill him by just stretching him out to meet the ends of the bed. And if the person happens to be taller, right, he would chop off the person to accommodate the bed. So this is a good metaphor for trying to understand what happens when we try to allocate task to durations to tasks. So either you will be too less, which your durations is too less, then you can have people chopping things off to show progress, right, which is bad. Or if the duration is too high, you have the impact of work expansion behavior, which is called student syndrome or the Parkinson's effect, right? So that's why the entire thing of trying to take a task and cut it by half, it doesn't play out, right? Because you don't know what you are really cutting. And so basically, as I said, all this that we are trying to achieve during planning is trying to achieve a very high on-time performance, and hence the solution is very planning heavy. It's very, very scheduling sensitive, right? Now, if you want to accept the fact that the initial plan made is going to be highly variable, then actually we end up questioning the very objective itself. That should on-time performance be the objective of multi-project environment, right? So here, what I am proposing is, because if you accept that scope variability is going to be high, and it is going to happen throughout the project, and it's very difficult to define where all it'll hit you, it is better to set another assumption which is not around due date, but the other assumption that we can, other objective that we can put forward is the objective of lower lead time of all the projects, right? The objective of now CCPM implementation in R&D environment should be lower lead times for all the projects, or in other ways we can say we want higher output of projects from a given set of resources. Now, when you give this as an objective, there are implications, right? What are the implications? The first thing is, we now suddenly are not so sensitive about how well we have made a plan. We are not sensitive about how well we have done the pipelining. But yes, we got to do everything possible to cut out the wastages of time and capacity that happens. All the wasteful behavior has to be cut out from the system. So the important point is that right now we subordinate to the export resources, which is typically the constraint in most of the R&D environments. You will have those 10-15 guys who are really the expert, who everybody looks around for whenever there is a trouble. So look at those expert resources and say that these are the guys who will who kind of control the output of the system. So important is to ensure that these expert resources are not multitasking, okay? And also to understand that since planning and scheduling is not going to take us anywhere, we have to give it up as a method to avoid multitasking. We can't pipeline projects and ensure that the load is maintained. We can't run a critical chain schedule which staggers the resources during the single project planning and expect multitasking to be cut off. What is really required is a WIP control system, a rule of one out versus one in. That has to be done at a project level, and at times not just at a project level but at a task level as well. So those kind of rules are very important, and if you see, those are very execution driven rules, that what happens in execution, we implement this kind of a pull solution to control the bad multitasking. Also, it's very important to understand that the original planned due date can change, so the longest path can also change, right? So when you have that, we now need to understand that the priority cannot be based on the buffer status, right? Because we don't know what plan we have made. It can undergo a change, so we cannot take the buffer signals as the real signal. Otherwise we'll end up making a mistake. Whatever we thought as the longest path right now, and if we decide to subordinate, we might end up, and in hindsight we found out that subordination decision was not correct, right? So it's very, very important that the so-called additional priority system around longest path, we need to be very careful for that, right? So it's very important, right, that we use token systems for priority, which means tokens of what is the number one priority, what is the number two priority, what is the number three priority. Use the token system rather than the buffer signal as a way to decide priority of projects, okay? And the token system is also inherited by the task. And also very important to understand is that a lot of CCPM softwares, they try to optimize around the longest path. Now the longest path algorithm, right, that's an added algorithm that people try to build in to create task level priorities as different from project level priorities. Now that's a complication which is not required, and at times it can be damaging. So I just want to show you an example how the longest path first algo can be devastating for a multi-project environment. So let's look at an example here. So let's look at a project which has got three tasks here, task A, B, and C, right? And we look at this lead time and we feel that we are not happy with this lead time. A plus B plus C, we are not happy with the lead time. So somebody closely examines the task A and finds out that actually task A can be split into task A dash and A double dash. Now here the color of the task represents what kind of resources are being used. So A requires blue resource, B requires green, and C requires the orange resource. Now here, so I found out that after innovating with people, that actually it is not that the task A has to be fully complete for task B to start. In fact, I can do a part of the task A, which is called task A prime, okay, and after that I can task B can start, and A double dash is required when task C is initiated. So wow, based on this thinking, I can actually in the planning stage I can reduce the cycle time. That's great, but very interesting to see here that the resource here, which is doing the blue resource, which is doing the task A, suddenly now has a window of opportunity. What is the window of opportunity? After he completes task A dash, A prime, should he continue to do A double dash? I think the answer is no, because it will be a waste of capacity, right? In a multi-project environment, he can afford to delay the start of A double prime, right? The way to do it is that this window of opportunity can be used actually to do another project. So let's see. So this window of opportunity, which is, we're getting a feeder path created. So we have this window of opportunity. I can take up another A dash task of another similar project, which is project 2. So along the longest path of project 2, I can pick up task A prime for project 2 as well. Now look at this, what has happened. When I stopped working from project 1 and shifted to project 2, okay, and I completed in that window of opportunity the task of project 2, but what has happened is that the window of opportunity for project 1, that means the time available to come back to project 1 has reduced. Now, what do I do when I get project 3? If the longest path first algorithm runs, then actually project 3 also I should take up the longest path task, which is again the task A. If I keep on doing like that, right? If I keep on doing like that, you will find out that if you keep on doing that, you will find out that you have delayed the project 1. Basically, suddenly this way of switching across longest path of many projects and opening many projects out can create an environment where you get into a complete desync, right? You start getting into a multitasking where everybody is kind of shouting because their feeder chains are getting delayed, because you picked up the longest path and you left the feeder path of the first project. So you went to the longest path of the second one, longest path of the third one, longest path of the fourth one, and by the time the first one has become critical, so you're not coming back at the project at the right time. So this is what I wanted to show you, the limitation of a longest path first algorithm in a multi-project environment. Okay, so if you see here, what we need to do here is get out of this so-called task level priorities, focus on a project level priorities, and have WIP controls, which is predominant way of controlling the execution. And that is how we will control the multitasking. Now, so then it opens up a fundamental question. Then what is the role of planning? What is planning meant for? Actually, the role of planning is to provide a good enough predictability of project completion date during the course of the execution. At any point of time, planning should be able to answer the question, okay, based on today's information, tell us where this project will end at, right? And that's it. That's the only role. It is an good enough estimate at any point of time when this project is going to get complete. It is not cast in concrete, okay? It can be in a range. For example, we are trying to we are doing currently a project with a biosimilar where project durations can be as high as a biosimilar product in pharma industry. The duration of new product development can be as high as 6-7 years. So what do you mean by a due date performance? Are we really talking about the date, right? We can say, around this quarter we can end, and that's good enough for many environments. In many environments, it's good enough to say, my project is going to end somewhere around, this month, okay, this quarter, this month. It's good enough, right? And that's the estimation is required, and it is an estimation, the latest prediction, right? but it is not a commitment. It is not something that one should subordinate to. One should not just expedite or recover buffer to meet that, because once you do that, you set up a trigger of bad multitasking all throughout. Okay, so basically what we are saying is no single project expediting based on project buffer status. So what should project review then focus on? Because the baselines are now gone, because the baseline keeps on changing. What should you focus when you are looking at a project review? So basically you have to be very careful when you're doing a single project review, because a single project review can be a local optima where you're trying to expedite a project. So very important to look at is, first is, in the pipeline, where are my multi-project queuing? Right, that's a very important question, and try to see where I can resolve. Where are my traffic jams? Like when you open up the Google Maps, you've got to see where are those red points where jamming is happening, and you resolve those jamming. You help all the projects, right? So that's the first view, which is a project agnostic view, and you take a pipeline view. And the second, the view that you take for the project is about issue resolution, right? What is the current issue that is holding the progress of the project, right? You focus on resolving that. So you have all the processes. You have the full kitting, you have your daily management, you have the gates, meetings. You have very good issue resolution. So what you get as a date from the planning process is the latest estimate of how well you have done all these processes, right? And that's the only thing that you can do. You can cut out the wastages. You cannot cut out the touch time. You cannot cut out the value adding rework. You should not cut it out, right? So what you can only do is cut down the wastages, right? So also very, very important to stop using fever charts, and because the fever chart can create it is a very beautiful graphical interface. It's a very good visualization of the data, but I feel it's damaging when you try to use it for review meetings in R&D environment. It can trigger a lot of wrong actions, right? And more important, stop using colors for buffer status, understanding for task priorities. Use the token system. So basically, what we have done here is try to move a lot of the problem solving into the execution phase. If you see, all the TOC solutions solves part of the problem in planning, right, and part of the problem in execution. So here we are trying to solve almost all the problems in execution. The problems of the wasteful behavior, multitasking, or your student syndrome, working without full kit. So all those things we are trying to solve in execution. What we are trying to do in planning is just trying to give a good enough predictability, and it's a predictability as of now, okay, and we give a predictability around a range of dates, that this is the best we can do. Now what happens is, what we have seen in implementation is that once you do the implementation and do a lot of improvement projects around the areas where the maximum wasteful rework is happening, or around areas where queuings are happening, you try to improve the predictability over a period of time. And what is the predictability that you improve to? You improve it around a range. For example, a 1 year project, you can improve the predictability around, let's say, 2-3 months, or on a multi-year project, maybe improve predictability around a quarter. And that's what is this solution all about. Okay, and I think it is much simpler to implement, and it does not become a planning heavy solution. It becomes a execution heavy solution. After doing this new approach, and our experience is almost every R&D environment, we are able to meet the objective of getting the output up, getting the lead times down, getting the chaos out of the system, getting the wasteful rework out of the system, and we are improving the predictability over the period of time. So if you ask me, did you deliver all the projects as per the date? The answer is no. And I would like to say that is not the failure, because that was never the objective in the first place. Thank you, everyone.